documenting the front lines of the AI revolution, the AI Rebels podcast.
And welcome to another episode of the AI Rebels podcast. I'm Jacob.
I am Spencer, and we are here with Alexander. Jake, say his last name. You had it way better than I did.
Naumenko.
Thank you for inviting me.
Thank you for joining us.
Coming on.
Just to start, Alex, what kind of just tell us about yourself? What led you into AI to start with? What were you doing before AI, if there was anything? We'd love to hear about it.
Yeah. So I am a software developer, and I have more than 10 years of experience now. But I wasn't really into AI, even though I started being interested in AI from 2018. So it's about 7 years now. But I really didn't have any practical experience in that area. So I was pretty much least likely person to contribute to the field. But when the war started, I needed some distraction from those stressful news. And because of that, I started just thinking about AI. And I needed to focus on something, and I selected NLP, natural language processing. And it was pretty lucky choice, as I see now, because starting from the top, because it works with symbols and concepts and the stuff, allowed me to discover some key principles behind intelligence and behind natural languages. And now I'm trying to share my ideas in those areas. Initially, I hoped that I will try to contribute at least something in some tiny area of AI, and now I hope to redirect the whole AI research agenda.
That's big. That's ambitious.
Yeah, and
that's
somewhat
fantastic.
humble.
Alex, can you, in layman's terms, in simple terms, tell us what it is now that you're focusing on? What are you researching? What are you thinking about right now?
So mainly I was interested in what concepts are and how language relies on them, on their usage. But now I am more into the algorithm behind intelligence. And I am not talking about artificial intelligence, I am talking about natural intelligence. And from what I discovered, I see that all life is intelligent. And in that, I agree with Professor Michael Levin, and he does a great job in his area, and I really enjoy that my ideas correspond to what he does. And I find some support from his work to my ideas, and that encourages me to continue in my research. But basically, it's intelligence, its components, and how those components work together.
Okay, can you give me an example of what it is that you're with this intelligence algorithm? Like, what does that look like?
Okay, so I like to mention frequently in my posts and in my tweets that intelligence is best demonstrated by the game 20 questions. And that game demonstrates the core algorithm. And this algorithm applies not only to intelligence, it applies to all cognition, all cognitive functions. And how I see it is, well, I defined it as the selection from available options of the most fitting option, given some relevant constraints. So let's consider the game 20 questions and, for instance, the task of object recognition. We have some object at hand and we want to recognize it. And we ask questions based on properties of that object. So properties of that object play the role of constraints in the algorithm. And all the categories known to us are available options. And then when we apply those properties that we check and compare to, and we filter, like select the best option from available ones. So applying each consecutive property of the object, we filter out non-fitting ones. And when we are down enough to the bottom of the tree, we are left with only those categories that apply to that object, because we took into account all the properties of that object. But really, that game teaches much more than just the core algorithm. Because,
I see.
for instance, if we going down, we introduce differences between different categories. But when we start ignoring them, we demonstrate what generalization is. The central topic of AGI, because AI is easy, but general intelligence is difficult for machines now. And it's that simple. Just ignore differences. And we are generalizing. But as I claim, we require equally both specialization and generalization. So
Related
going
to
down the
intelligence.
tree and going up the tree.
Okay.
And it depends on the task which we pursue at the moment, because at different levels of the specialization tree, different rules apply, and it may be relevant to the task or task dependent.
So what's the biggest difference right now between what you're proposing, this neural pathway, this way of structuring intelligence, versus where AI is at currently with its reasoning capabilities and all of that?
So basically, so far we had two major approaches to AI. The first one was good old-fashioned AI, and it was relying on rigorous logic. And I claim that rigorous logic is not applicable to intelligence. First of all, because it is impossible to reach like ultimate precision.
And is a good way to maybe, is this like a if-then statement, this rigorous logic you're thinking of?
Yes.
Is that maybe a good example? Okay.
Yes, but often we have those like vague moments when we are not sure, is it day yet or is it already night? So that twilight zone in between. So, and those areas are quite common in real life and in real life scenarios. And we shouldn't forget that we are real-time animals. We need to make decisions fast, immediately, like within 1 second. We do not have time for like selecting different, developing new approaches. and we only have what is available to us at the moment, and we may either apply those or go somewhere else and find something else. So, and because of that, rigorous logic is not applicable, as I see. And also, intelligence is definitely not relying on statistics, on guessing. So we do not predict our future actions. We select actions. And I like this example of Roger Federer, who is contemplating the shot. And if he is predicting that that he will miss the shot, he wouldn't go with it, right? It's unreasonable. But he selects the manner in which he will perform the shot. That's it. And then che sarà sarà, Italian phrase, which means be it what it may. So we selected the best way to proceed, and then be it what it may. So
Yeah.
we cannot reliably predict future, and but we can select, given our current knowledge, what will work best for us. Given our current knowledge, what we know so far. If we have some gaps in our knowledge, it's a completely different story. We need to fill in those gaps, and because of that, we may decide to go and experiment and collect necessary evidence to know how to behave in the future. And that also is one of the critical pieces that I consider novel in my approach, because, for instance, in reinforcement learning, we rely on known reward function. But in case of unknown recipe, we cannot calculate that reward. We do not have any reliable information to use. And I claim that collecting this information may be even more important than the success as such. And because of that, filling those gaps in our knowledge is kind of reward in itself. The same applies to failures, because if we fail at something, it just means that what we didn't lead to those results that we wanted, but it definitely led to some result. And we should analyze how those parameters initial led to that result. And we then will have that information to take into account when we select how to behave in similar situation.
There are a few studies out there that have shown that the impulse to act occurs in the brain before the conscious realization of that impulse to act. And so a lot of our rationalizations and reasons for doing things are post hoc rationalizations, right? You know, we make the decision subconsciously and then we rationalize it with what we know. I'd be curious, how do you think that your kind of theory of intelligence interacts with that phenomenon?
How can I explain that, right?
Yeah.
Yeah. So I am perfectly fine with intuition and subconscious. So when we when we interact with the world, we subconsciously collect information about how different parameters lead to different results. Like in the along the idea of Einstein's definition of insanity,
Mhm.
right? Doing the same thing over and over, expecting different results. But in fact, we observe how different parameters lead to different results. And because of that, our intelligence works again by chopping. So
Mhm.
if we observe that some parameter always lead to some result, then we know that, okay, this parameter is responsible for and is relevant to that result.
Mhm.
And again, if some result is always different, no matter how we change that particular parameter, then that parameter is irrelevant.
Mhm.
And this relevant versus irrelevant is pretty much important for intelligence.
Mhm.
And it is pretty good at spotting what's relevant and what's not. And it keeps in mind, keeps in memory what is relevant for each particular action. So I consider that actions are like building blocks. So
Mhm.
they stand aside in our brain. So we consider each action separately,
Right.
and we track how different parameters are relevant or not to that action.
Mhm.
And because of that, for each action we have some set of algorithms, behaviors, recipes to select from.
Mhm.
So what and we or we can say that it is about the result that we want to achieve. So uh, that result can be achieved by using those different actions, and we know that they lead to that result. So we may select from them. So that's the idea.
Mhm.
And what you were talking about is that some of those realizations internally,
Mhm.
they do not need to be rationalized or communicated to other
Yeah.
people because they are too tiny or too subjective.
Right. Yeah.
So if I know how to play snooker, for instance, and how to kick balls, still you will need to develop the skill on your own.
Right.
And we can only discuss like high level stuff. So just try to kick it sideways or uh, push it forward, the cue ball or whatever. So, but the tiny details are connected to each individual. That's why, by the way, it is necessary probably to really develop some skills with connection to particular instance of the to particular agent, so to say,
Yeah.
be it robot or human or whatever. So, and what it brings us, that internally in our head we have tiny details and large details. We we can talk about large details like generalized
Yeah.
versions, but not small details, because we do not consciously aware of them.
Yeah.
So and that makes, but intelligence is aware of them. He knows about them and he takes them into account. And because the whole mechanism relies on just quick comparisons of quite limited number of features, then it works like instantaneously, and we intuitively know what to do in each situation in real time.
Mhm.
But sometimes those decisions may be not so perfect or rational or whatever, but it perfectly can be explained by our past experience. Because
Interesting.
we think that that information that we acquired in the past is basically what we know, what we can select from. So
Yeah.
we cannot apply what we do not have at our hands.
Yeah. So, okay, I think it's starting to make sense to me. I think I'm getting there. But I'm curious with artificial intelligence in its current state. Obviously, its intelligence is completely based on the data we have fed it, right? It has no solid, at least at this point, solid interaction with the external world. It's fed data and it responds accordingly. But what you're saying, do you think is it possible for AI to get to this level of intelligence without having these human experiences?
It is possible. So what I'm saying is that, for instance, when we categorize objects, we follow this procedure described in the game 20 questions. So we introduce those differences, like is it tangible? Is it alive? Does it is it animal, or does it feed its cubs with milk, and so on. So and you see, we only have few comparisons, few features, and we already down to mammals. But imagine what neural networks do. They are fed with whatever information they are fed. For instance, number of limbs, the type of skin, and size, weight, and so on, and
Yeah.
probably average life expectancy. Is it enough to indicate that that animal is mammal? No, the defining feature is not there, and it doesn't know about it. It has to go with what it was fed with. So because of that, they uh, they they do not rely on the proper defining features. And that 20 questions game, it teaches the importance of defining features because they are relevant. All other features are not. So if I am talking about that some features define some animal as a cat, do I need to consider weight, size, color, and so on, name as a defining feature? No. And it brings us to one crucial misconception about current AI approaches. They rely in their categorization, and it really applies to anything, because everywhere we work in AI or in cognition, natural intelligence, we need to match patterns, right? And it's basically categorization. And current approaches rely on similarities. So they consider cats and try to figure out what makes cats similar. So what brings them together?
Right.
But in my approach, cat is defined not by the similarities with cats. It is defined by differences from anything else. So
So what?
we
Oh, go
have
ahead.
internal set of cats, and we have external set of anything else.
Yeah.
Defining features they differentiate cats from all other animals, and not only animals. Because, for instance, if we consider one interesting theory, exemplar theory, so it explains that we recognize objects by comparing them to exemplar of that category.
Mhm.
But how many categories do we know? Like millions, right? And do we compare a given object to a million categories? No. We
Right.
go by eliminating roughly half of the possible categories by following the 20 questions procedure.
Mhm.
Is it tangible? And immediately love, democracy, justice are given away. Is it alive? Yes, no. So mountain is no longer considered. And immediately we narrow down the possible, and because of that, when we are down to cats, we probably checked only 10 comparisons.
Mhm.
That's it. But if we are talking about comparing 1 million categories, we have even more problems with that approach, because what are the defining features to compare?
Yeah, this is
Color, weight, size?
This is
Right.
reminding me of the old apocryphal story of, I think it's Socrates on the Agora, and they're trying to define what is a man, and Socrates comes up with the definition of a featherless biped, and then Diogenes shows up the next day with a chicken that he's plucked all the feathers from and says, "Behold, a man." Reminds me a lot of that.
Yeah.
That's exactly why trying to come up with features based on the class instances,
Yeah.
it's useless.
Right.
So
Yeah.
we need, and one more key aspect of this key observation, we cannot come up or suggest one concept,
Mhm.
like not connected to anything else.
Right. Right.
Yeah.
So there is a Russian saying, which is roughly translated as everything is recognized in comparison. We need at least two concepts.
Right.
And we need to know what differentiates them.
So
yeah.
This is fascinating. So you're wanting to essentially one, I'm gonna like say some things back at you and just correct me if any of it's wrong. You're trying to one, decode the way the human brain reasons through recognition and decision making.
Yeah.
Does that sound about right?
Yes.
And with that, it's taking that reasoning of the 20 questions. So with AI as it stands, what kind of an effect would this have? What benefits are there to adopting this?
Okay, so first of all, there was a funny example in Twitter, this problem of a farmer, wolf, cabbage, and a goat.
Mhm.
But there was a bridge mentioned, and the LLM in question started to enumerating all those steps that take the goat to the other side, go back, and so on. So it didn't consider that bridge was in any way relevant to the task. But we all know that it is.
Right.
But what if something else was mentioned, like a tree? It is irrelevant, okay. But LLM doesn't know the difference between relevant and irrelevant parameters to the task. And if it was trained that in such and such task, when goat, farmer, cabbage, and wolf are mentioned, list those steps and you will be fine.
Mhm.
But change those parameters to like ogre chocolate and some small girl, and you will be making new game altogether to the LLM, and it will not know what to do with it.
Mm-hmm.
But the task didn't change at all. So that's what I'm talking about, relevance and not. And this relevance is one key that will change a lot in what we have today. But what I propose additionally is this concept of defining features, because really we will faster recognize objects, we will perform much fewer computations. And by the way, this allegory of computation inside our head, we need to specialize it better. It is comparisons. So what I'm talking about, that when we perform some reasoning inside our heads, we are relying on our internal representation of some object. And we operate with all the knowledge that we have about that object at that moment. But when we talk about it, we mention only its differentiating features. So like category. But in fact, each action relies on the subset of the properties of that whole object. And this is a very important concept, because when we see how large language models produce their answers, they most likely rely on mentioning those algorithms applied by humans and described in different sources that were included in the training set. But this is not obvious, and it's not directly follows the general process and the general workflow, because when we talk about stuff, we do not rely even on the required properties of those objects. Let me demonstrate on a very simple example. So if I say take a seat, I pronounced only like 2 words, right? But in those words, is it possible to encode the location of a chair or some other instance of furniture which is sittable, right?
Yeah. Right.
So how can you perform this action? What I did, I only invited your cognitive abilities like perception, reasoning, memory, imagination, even, to perform all the necessary heavy lifting to perform that command, that request, right? But the cognitive heavy lifting was performed by your other cognitive abilities, and that's what I consider is important. And it turns out that language doesn't rely on those. In effect, language only invites attention of the listener, of the reader, and that's it. And then other cognitive abilities kick in, and but in language those details are not encoded, and that's very important. And what we have in LLMs is they lack those additional cognitive abilities to compensate for the lack of that information. And that's crucial. Because of that, we will require multimodality and so on. And in fact, we will need even to fine-tune those knowledge to each agent individually. So there's a lot of work to do with this approach, and unfortunately, we are too invested in the old ones, and this Japanese proverb saying that when you are on the wrong train, you'd better to go off quickly and turn back. Unfortunately, we are not going off the wrong train so far. Hopefully, I will at some point succeed in this mission, and some company, hopefully in big company, will get interested, and they will at least try to check if this approach will be in some respect better and promise better results, be more efficient in terms of resources, more meaningful in terms of answers and value delivered, reliable as well. So there are many promises in this approach, and I hope it will see the day soon.
It reminds me a lot of stuff that Jan LeCun says about, and he's backed off slightly from this, I believe, but stuff that he says about LLMs not being as smart as a house cat. Because, on one level, that's very wrong, but on another level, it is very correct. Because you think about what a house cat needs to survive and the internal models that it needs to be able to create to navigate the world, right? Like, my cat jumping up onto the counter, like he's created a pretty sophisticated internal model of the physics involved in making that jump. He just doesn't have the other aspect is the language to describe those models externally.
Yes.
But yeah.
Right.
Yeah, it's
yes,
fascinating.
But imagine a cat injured leg.
Yeah.
All those internal parameters no longer work. It will need to adjust internal model and return to the original one when the leg is healed. So, imagine retraining from scratch all those models. It's insane, and
Really is.
it is not necessary, because all we have to do is take into account additional constraints, right? Selection from available options respecting relevant constraints. So if one leg is injured, so I will move in different manner. I will not jump. I will not rely on the injured leg, and so on. So very simple, and it corresponds to the favorite definition of Michael Levin: achieving the goal no matter what constraints are in front of you. So you apply different algorithms, and you find your way, so to say.
Yeah.
And
so obviously it's being talked about so much right now, is this idea of deep seek, all these different things, that the training the models, fine tuning the models. With your approach, what does training a model really look like? Because it's not as much, here's the data, here's how to work with that data, interpret the data. It's much more, it's like much more multimodal, almost like here's the cat, right? We love cats.
yes.
And here are all the different parts of it. I'm trying to envision what this looks like to train a model this way.
So basically, what we will have to do, we already have a lot of information encoded in texts. So it is okay to go with text so far, because I don't do perception. So I cannot like provide accurate algorithm on how to do vision, audio, smell, taste, and so on. So so we will need to work on that, and I believe that these principles will apply there as well. Just
Okay.
we need to take into account relevant constraints again.
Yeah.
But what I'm saying, that we need to construct those specialization trees. So if we are trying to affect, for instance, location of an object, so we can kick it, we can push it, we can move it in any way, with air, with some pressure, or we can ask someone else. So many approaches, and we need to know how different actions and their intensities or other parameters apply and lead to which results. So, and that what I mean is by knowledge how. So recipes. So we need to work out those recipes. It is quite possible to collect a lot of such information from texts. Of course, we will need to work out the details as soon as we have the need for this additional information and additional details, like in different kinds of robots and machines and so on. And it is possible to then, when we processed all those texts and filtered out irrelevant ones, like hallucinations or hypotheses that went wrong and were refuted and so on. So, but then we will still have some gaps in knowledge. And that's when we, in fact, it will be LLMs, not LLMs, this novel AIs. They will instruct us on how to experiment in order to fill the gaps in this refined knowledge.
Interesting.
So, and it will be possible for this new type of AI to like lead us in generating new knowledge and bringing us closer to new discoveries, really. So, and that's definitely different from what LLMs can do for us at the moment. And as I say, it will be done in a pretty efficient way without so much resources wasted.
Yeah. That's what. Yeah, I wonder.
And it will be really one-time training, because we will not need to repeat the same joke twice even.
Once that tree is built.
Yeah. The only thing that may be interesting is, for instance, if different authors mention the same joke, then we will probably need to know just references, that author and that author mentioned it. Okay, so for references only, or that joke was mentioned 20 times and that joke was mentioned 100 times. So okay, that one is more popular. Okay, just to know the basic statistics, and that's it. Or it applies not only to jokes. I hope you understand. So
Yeah, that makes sense. Wow, fascinating.
But again, it's one-time training, and sometimes it's not even training in just updating a parameter. For instance, if you have a bunch of friends and one of them betrays you, you just update this property unreliable, and that's it. Next time you need to ask someone, you do not retrain all your historical data, right?
Right.
You just select from the set of reliable friends,
Yeah.
and that's
Right.
it. That friend
Right.
is no longer reliable, so
He's out.
he's filtered out. So the same process applies. So
Okay.
selection with respect to properties.
Yeah. Maybe you should build your own 20 questions game, Alex.
Well,
I would love to play it.
there are many really versions of it online even. And by the way, that game was interesting to famous American philosopher Charles Sanders Peirce, but he failed to understand the full potential of that game. Again, because Peirce was more interested in rigorous logic.
Yeah.
And that game is not so about rigorous logic, right? So
Yeah.
Yeah.
it's about,
Well,
and by the way, I start to call my approach semantic binary search after that game, because
semantic binary search.
essentially it follows the idea of binary search. It divides the remaining like the currently remaining options roughly into half, but it relies on different properties each time. That that makes it semantic.
Yeah.
And at each level we have like different kinds of properties to continue with based on the previous answers, really. So that teaches us a lot about what properties to expect next.
Yeah.
And
Yeah.
it's
This is, I mean, what I'm loving as I'm hearing this, obviously we're called the AI Rebels podcast, right? Because we try to
and
feature and
I I
highlight.
I loved how my approach is
Yeah.
fine-tuned
Rebellious.
for your format,
Well, you're
because
rebelling against the rebels, which
well,
is just
I am
like so
rebelling
poetic. I love it.
against current approaches. So
Yeah, right.
and I'm trying to like redirect the whole field, the whole discipline into new direction, because really
Hmm.
we don't want to stay on the wrong train.
Yeah, I mean, there's
And
something there because we're already seeing it with the currently, it seems the thought process, right? Like the answer is more data. Oh, okay, we're running out of data. Let's use synthetic data. Okay, now DeepSeek is doing it at a fraction of the cost, and now it's going to be a race to the bottom. It's how far can we go with the current model? I think it might take something like this, a rethink of the logic and the system that we're using. I think you're onto something. I think something like this is what it's going to take to really get AI to that true AGI level that a lot of us think of when we think of AGI.
yes, and you already mentioned Jan LeCun, but the problem is that a lot of experts call for a new paradigm, right? But they do not propose one.
Mm-hmm.
And for instance, Jan LeCun proposes his own version of what can lead to AGI, but it is relying on the same deep learning methods, and so basically we need a new approach. So let's add one more layer to the neural network. It doesn't work that way. If you need
Mm-hmm.
radically new approach, then probably you need to get rid of those neural networks altogether. So
Right.
basically, what I propose, of course, you should remember the AlphaGo impact,
Yeah.
right?
Yeah.
But do you remember that it relies on the tree search, and effectively that's what I propose. The only difference between Monte Carlo tree search and my approach is that I propose a quick comparison of existing properties to check with which option to go next, and
Okay.
not rely on this Monte Carlo simulations, really, which take long, and it makes the whole process. But again, if we will talk about the approach to beat Go, then I will consider different kinds of AlphaGo algorithms. So
Yeah.
basically, we need to consider options for the task. And if we don't know anything better, then that's the way to go. So
Yeah. Yeah. Amazing. Well, Alex, thank you for coming on. As we wrap up, I've been wanting to ask you, as we've been talking about this, what is your definition of AGI?
so again, I do not define AGI because it's a model of intelligence, right? So I defined intelligence. So basically, because a lot of folks try to avoid that topic because it's too difficult for them. And for me, it's not difficult because I know that intelligence relies on differences. So my definition of intelligence is the ability to handle, in all the forms possible, to handle differences, recognize them, process them, and produce them. So that's it. Do you remember what Heraclitus said about the river? That no man can enter the same river twice.
Right.
Because it's not the same river, and he is not the same man. So everything is unique. But I continue that for some purposes, some objects are interchangeable. And we should know the difference between relevant, irrelevant, interchangeable, or different. If we know that, we are fine to go. And rely on simple comparisons.
Fantastic. Well, Alex, if
Yeah.
people want to follow this rebellious journey of yours, what's the best way for them to do that?
Well, I have a Twitter account, and I have Substack page where I post my ideas, and I am open for all sorts of collaboration or discussions.
Great.
And by the way, I am even ready for pivot in my career, so from software development to AI research. So and you can say that I'm pretty interested in that. So
I can tell.
it
Yeah,
will
I
be
can tell.
definitely exciting pivot for me.
Yeah.
Yeah.
That's awesome.
We'll drop links and we'll spread the word.
Yeah.
Thank you for that. Appreciate that, really.
Thank you
And
so much for coming on.
and it was great discussion. Thank you for
Yeah,
your
this was great.
questions, guys.
Yeah,
Thank
thank
you.
you.